All right, in today's lesson, we're going to start solving quadratic equations algebraically. Now, there are 4 ways you can do this. Today, we're going to explore the first 2, factoring and extracting square roots. In the next lesson, we'll do completing the square and quadratic formula. But let's just do factoring and extracting square roots. So I'm going to start with factoring. So this hopefully is review for you. But when we do factoring, remember there's kind of 2 kinds. You can do the GCF, where you just take a one term. Or you could do box method, you could do grouping, however you learned factoring. I'm going to model grouping, but if you learned it a different way, that's fine as well. Let's start with number 1 here. 6x squared minus 3x. Now, I want you to notice the x squared is positive. You always want that to be positive when you are factoring. So I need to move everything else towards that x squared. So if I move the 3x over, I'll have 6x squared minus 3x equals 0. Now, I only have 2 terms. So if there's only 2 terms, that's where that GCF comes in place. So what do these 2 terms have in common? A 3 and an x. So if I divide out a 3 and an 3x out of that first term, I'll have 2x left, and then I'll have a minus 1 where that 3x was, and it's still equal to 0. So to solve this, I set each part equal to 0. So I'll set 3x equal to 0, and then I'll set the 2x minus 1 factor equal to 0. This solves out till x is 0. This, I move the 1 over, divide by 2, so x will equal 1/2. So I have 2 answers. It's quadratic, so I should have 2 answers. Let's look at number 2. 9x squared minus 6x equals negative 1. Well, that's a positive x squared term, so I want to leave it there. So I'm going to move my 1 over. Okay, now it's a trinomial. Now, there's not a GCF I can take out of each term, so I need to do grouping. Now, to do grouping, I'm going to multiply to add, or to multiply to get a times c, 9 times 1 is 9, but I need to add, whatever I get needs to add to the negative 6. All right, so what multiplies to 9 but adds to negative 6? That would be a negative 3 and a negative 3, right? So when you're doing grouping, what you're going to do is take the x squared term and rewrite it. The middle term, you're going to not write it like that anymore. You're going to write it just like we had in the table here. So minus 3x, and then the plus 1 will come right down. Now we group terms in 2's and do GCF. So the GCF of my first 2 terms here is 3x, and that leaves me a 3x minus 1. Then bring that sign straight down. And the last 2 terms don't have anything in common, so I'm just going to put a 1 there. But I am taking a negative 1 out, so be careful with that negative. It's like I'm dividing by negative 1. So I'll have a positive 3x minus 1. Now, if you notice, this 3x minus 1 and this 3x minus 1, I can pull that out. And then look what's left over. I have 3x and a minus 1. So this is my second factor. All right, yes, they do match. So I could write it as 3x minus 1 squared. But let's just solve this for 0 real quick. Move the 1 over. So I'll have 3x equals 1. So x equals 1/3. Okay, both factors would end up with the same value since they are identical. Now let's look at number 3. 2x squared minus 3x plus 1 equals 6. All right, I want to go towards where the x squared term is positive, so I'm going to move the 6 over here. So I'll have 2x squared minus 3x, and it'll be 1 minus 6, so it'll be minus 5 equals 0. So now I need to do my multiply add chart to figure out what factors I need. So 2 times negative 5, it's going to multiply to negative 10, but add to negative 3. So what 2 factors multiply to negative 10, but add to negative 3? So 5 and 2 would work, but I need the 5 to be negative and the 2 to be positive. So when I rewrite this, I'm going to have 2x squared minus 5x, so I'm not going to write the 3x anymore. Then I'm going to do plus 2x minus 5. All right, it doesn't matter which order you put these in, by the way. You can do it either way. Now we're just going to do GCF. What can I take out of these 2? An x. That's about it. So I'll be left with 2x minus 5. Bring that plus sign down. And what can I take out of these two? Nothing, just a 1. So it's x minus 5, or 2x minus 5, sorry. Now my 2x minus 5's match, and they should. If you're doing it correctly, that factor should match. So I have 2x minus 5, and then what's left over comes over here, so it'll be x plus 1. Still equal to 0, so I set each of the factors equal to 0 and solve it. So 2x will equal 5, divide by 2, x equals 5 halves. And then I bring this one over here, so x plus 1 equals 0, so that means x is negative 1. All right, let's look at number 5. Nope, 4. All right, everything's on one side of the equal sign. That's lovely. And x squared is positive. So we can go straight to multiply add. So I'm going to multiply to get a negative 6, but I need to add to get a positive 5. All right, so 6 and 1, but the 1 needs to be negative for that to work. All right, now let's rewrite it. 2x squared plus 6x minus x minus 3. All right, let's do our grouping. So I'll have 2x and I'll have x plus 3. Bring the minus sign down, and then there's really nothing I can take out of those two, so I put in a 1 as a placeholder. And then I divide both of these by negative 1, so it'll be x plus 3. So my factors will then be x plus 3 times what's left over, 2x minus 1. And if I keep on solving, x plus 3 equals 0. That means x equals negative 3. So if I put 2x minus 1 equals to 0, move the 1 over, and divide by 2, so that means x will be a 1/2. Okay, hopefully you're getting this. You remember how to factor. Let's try another one, number 5. If I do my multiply add chart, I'm multiplying to get 3 times negative 2, which is negative 6, and I need to add to get a negative 1. So a 3 and a 2 would work, but I need the 3 to be negative and the 2 to be positive. Okay, so let's rewrite this. 3x squared minus 3x plus 2x minus 2. Let's group. We'll get 3x, and we'll have x minus 1 plus, what do these have in common? A 2. That'll be x minus 1. So then I'll have x minus 1 times 3x plus 2. Set each one equal to 0. Solve it. So x is 1. There's one of my solutions. And then 3x plus 2 equals 0. So 3x equals negative 2. So x is negative 2/3. All right. Look at number 6. All right, number 6. 8x squared minus 33x plus 4. All right, some bigger numbers, but we can do this. So we're going to multiply to, they have to multiply to a 32, a positive 32, but they need to add to a negative 33. So that would have to be a 32 and a 1, but they both need to be negative in order for the product to be positive and the sum to be negative. So let's plug those in. So 8x squared minus 32x minus x plus 4 equals 0. All right, first two terms, all I can take out is an 8x. That leaves me with x minus 4. Bring down the minus, and then these two don't have anything in common, so I'm just going to divide by negative 1. So it'll be x minus 4. Then I have x minus 4 times 8x minus 1 equals 0. Set each factor equal to 0, so x is a positive 4. And then 8x minus 1 is 0. Jump that 1 over. Divide by 8, so x is 1/8. All right, there's my two solutions. Now, let's turn the page and try some more. Okay, so on this page, we're going to look at the solving by extracting square roots. Now, before we just jump into taking square roots, what we want to make sure we do is isolate the square root, the squared term first. All right, that's a big deal. You want to isolate that first before you do any square rooting. Okay, so like number 7 is a great example. Here's my squared term, x squared, right? But that 4 is hanging on. It's not totally isolated. So I want to divide by 4 first. All right? So that gives me x squared equals 3. Then I have to take the square root of both sides. Now when you take the square root, there is a rule that says if you take an odd number out of an even index, which is squared root, then you have to take the absolute value. And it's the absolute value of the square root of 3. Now, remember from Algebra 2, when you have an absolute value, you have to consider, to move from absolute value to just x, you just have to consider the positive and the negative results. So I always have to put plus or minus with it. That's what that means. Let's look at another one, number 8. Isolate the squared term first. Well, this whole thing is squared. That 1 out here is not a problem. We're just going to leave it be. So we've done the isolating part. Now we just take the square root of both sides. Same rule applies. When you take it out, you have to put it in absolute value bars and then get rid of the absolute value bars by rewriting it as a plus or minus square root of 7. Now we're not done because we don't have x equals. We need to move this minus 3 over. So this will become x equals 3 plus or minus the square root of 7. You always want to put the radical in the back, by the way. But that's the way you can leave your answer. Since 7 is not a perfect square, you don't want to go any further because then you'll have yucky decimals. Let's try number 9. All right, 2x minus 1 squared equals negative 9. Now, the squared term is isolated, so we can go right into the square rooting. So when I take the square root of this, I have the absolute value of 2x minus 1 equals, now the square root of 9 is 3, the square root of negative 1 is I. Remember that? So 9 is a perfect square, and then negative 1 is a perfect square with the imaginary numbers we just talked about. Now I want to get rid of the absolute value bars, so I'm going to say 2x minus 1 equals plus or minus 3i. All right. Now I need to solve it for x, so I'm going to add 1 to both sides. So I'll have 2x equals 1 plus or minus 3i. Remember, when we put it in standard form, the imaginary part has to sit in the back. Then I divide through by 2, and I can leave my answer just like this. X equals 1 plus or minus 3i divided by 2. And there it is. One more, and we'll be done with this lesson. This one, the squared term is isolated, so I can go right into my square rooting. I have the absolute value of 3x minus 2 equals the square root of negative 6. Now, that's kind of a yucky number, right? Square root of negative 6 is what? I square roots of 6. Nothing great about that, but that's how we're going to rewrite it. Now, to drop the absolute value bars, we need 3x minus 2 equals plus or minus I square roots of 6. Now we need to isolate x over here. So I'm going to move my 2 over. 3x equals 2 plus or minus I square roots of 6. Then I divide through the whole thing by 3. So my final answer will be 2 plus or minus I square roots of 6 divided by 3. And that's where you leave your answer, okay? Resist the urge to do any canceling under the radical. You can't do that, okay? That's a party foul. Can't do that with math. Now, hopefully this makes sense. I'd love for you to try the in-class portion. That's where we're going to start when we get to class next.